Question deals with what? Bandwidth of various signals. First of all, audio signal +1. We refer to the first part. Audio signal +1. This is sensitivity of air. Sensitivity of ear. Frequency. Yes, values. 20 hertz to 20,000 hertz. And the maxima is at 1000 hertz. This is what sensitivity of ear is. So, this is written as audio signal. Bandwidth is approximately range. First part is range. Range is 20 hertz to 20,000 hertz, 20 kilohertz. This is range. Bandwidth means difference of the frequencies. Bandwidth. Yes, 20,000 minus 20, almost equal to 20,000. So, approximately equal to what? 20,000 hertz, 20 kilohertz. This is one. Audio signal. And before this audio signal, there is one statement written, that is speech signal. What is the difference? Speech signal value is given 300 hertz to 3100 hertz. What does it mean? Anyone? Bolo. Ki fark hai? Audio signal and speech signal. Anyone who can answer? Correct. Audio, something, it's ability of the ear. It can music, any sound. It can be human voice also. So that is the value. It is ability of your ear, that it can detect 20 hertz to 20,000 hertz. But when you speak, then that is what you call as a speech signal lies. Range is what? 300 hertz to 31. Even if you remember 3000, won't make much difference on the graph. Yes, 300 hertz. This is 20, this is 1000. I can mark it somewhere here. Agreed? 3000, this is 1000, this is 20,000. I can mark somewhere here. Your ear can listen to 20 hertz to 20,000 hertz. Out of that, it can be music, it can be some noise by the fan, it can be some animal voice also, it can be anything. Out of that, human voice. वो भी तो सुनता है कि नहीं, मैं बोल रहे हैं सुन रहे हैं तो उनके नहीं, ठीक है? So जो मैं बोल रहे हैं, that falls in this range. That is why this is what speech signal. Third part which is written is television. Refer to NCERT and give me the page number where you have a television frequency range. Running box 519. Television, one is 54 to 72, then 76 to 88, 174 to 216, 420 to 890. If we pick up one value, say 76 to 88, suppose I pick up this value, 76 what? Megahertz to 88 megahertz. Suppose, because 88 तो आगे की शुरू हो जाएगा FM radio. So 76 to 88, easy to remember, otherwise there is a set of frequencies. 76 to 88 as per NCERT, it comes out to be, this is the range, bandwidth. As per this, I repeat, as per this it comes out to be, yes, how much? 12 megahertz. Nothing to worry about, notes it is at a 6. It simply gives you approximate value. For example, if you take 54 to 72, then what is the bandwidth? 54 to 72, yes, 18. So it depends what set of frequencies you take up, but approximately it is 10 megahertz, you can say. The bandwidth for TV signal is 10 megahertz. Time with you is 4 minutes. 4 minutes to write. Question number 6 deals with what? Yes? Need for modulation. What is the need for modulation? What is modulation before that? The process of superimposing the message on the carrier wave. A message, carrier wave will carry this message, gets transmitted, travels say through air or wire, and a receiver will receive this and will take this message from the carrier wave. That is a demodulation. The question is, what is the need? How many points are covered? Size of the antenna, power, mixing up of signals. Time with you is 2 minutes. Go through first part only, 15.7, first paragraph only. 2 minutes. If you don't have NCERT book, pray to the Almighty. There's a better option. Let's go through the content. As already mentioned, the purpose of communication system is to transmit information or message signal. That's what communication is. Message signals are also called baseband signals, which essentially designate the band of frequencies representing the original as delivered by the source of information. Let us do this. Source. This is source of sound. So let us take this as an example. The volume first increases, then decreases, say it is this one. Suppose this is the signal. It is represented like this. And if you record it, it will look like this. It is equivalent to, it is not any signal, it is not a single sine wave, it is one sine wave plus higher frequency plus still higher frequencies. You term this as A naught plus A1 sine omega t plus A2 sine 2 omega t and so on. Every individual's voice is also having these harmonics, harmonium. That is how, if you feed, when I say a word, say fan, if I say fan and if you say fan, there is a difference. How you recognize the voice of a person? Just see how your brain works. Your brain will recognize on the basis of the same concept. That is how a given signal, sound or a word by individual, we get harmonic analysis of every individual voice, and it is different for a different person. Like your thumb impressions, you have your voice harmonics also. That is how the various crime agencies will detect whether it is by one person or someone else. Famous case, याद है केड़ा दस्या सी तुहानू? Famous case is Salman Khan case. Aishwarya Rai complained to the police, Salman Khan has threatened. So the voice was recorded, samples were taken, then harmonic analysis was carried out, and it was concluded that it is not Salman Khan, it was someone else doing it. So the organization which does it is Forensic Lab, Hyderabad. They do it. There are a number of other, even at Bhatinda you can do it, but this is what. So that means one signal. Now we go through the content, one part, that is, no signal in general is a single frequency sinusoid, but it spreads over a range of frequencies called signal bandwidth. So there are a number of frequencies. Suppose we wish to transmit an electronic signal in the audio frequency range, audio, sound, baseband signal frequency less than 20 kilohertz. So the example here is, let us take this value 20 kilohertz. less than 20 kilohertz, let me say equal to 20 kilohertz. Over a long distance directly. Now my voice is being conveyed to you directly without any modulation. It is direct, but what you are getting from radio station is modulated. So we will compare the two. Let us find what factors prevent us from doing so and how we overcome these factors. Time with you is 2 minutes to write this part. 2 minutes to write this part only. First issue is, yes, size of a antenna. Go through the content. In case it is 20 kilohertz, then what? In case it's 1 megahertz, then what? NCRT only. You not read any other book. It is of no use. It will be wastage of your time. If you have NCRT, you can go through. Rest, prayer, simple. Size of antenna is approximately what in comparison to lambda? Written somewhere, underline that. Lambda by 4. So you have option 1, without modulation. Frequency 20 kilohertz. Wavelength is equal to speed of light divided by frequency. Speed of light is how much? 3 into 10 power 8. 20 kilohertz, 20 into 10 power 3 comes out to be how much? In kilometers. Yes, in kilometers comes out to be what? Yes, check please. 10 power 3, 10 power 3. Yes, 15 kilometers. Lambda by 4 is equal to 15 by 4, approximately 16 by 4, it is 4 kilometers. Length of the antenna is 4 kilometers. Tallest building in the world is 1 kilometer. And with this arrangement, what you are suggesting is that make a tower of what height? 4 kilometers. 1. Option 2. Frequency say megahertz, of the order of megahertz, even if it is 1 megahertz, then lambda is equal to speed by frequency. Speed is how much? 3 into 10 power 8 meter per second. Frequency is 10 power 6. 300 meters. Lambda by 4, 75 meters. This is workable? Few meters, yes. Few meters, 25-story building, 75 meters means 25-story building. 25-story building is not a big deal. You can make a tower of this size. Time with you is 2 minutes. Antenna size. Without modulation, this is what the result is. With modulation, this is where you are. That is why you modulate. That is why you need to modulate to reduce the size of antenna. Second point is what? Effective power radiated, or you can say the issue is power. Power is formula. Power is proportional to 1 by lambda square or proportional to square of a frequency. Option 1, without modulation. Frequency is low. With modulation, frequency is high. So power will be low. Power here will be high, because power is proportional to square of a frequency. What you need is powerful transmitters or low power transmitters. Powerful transmitters, because like if you have a powerful bulb, you get more light. If you have a powerful tower, you get a better signal, quality signal. That is why effective power is more for high frequency. Time with you is 2 minutes. 2 minutes to write. Anyone who can explain? This is out of the given, very simple to explain, mixing up of signals from different transmitters. What does it mean? Anyone? कर सकता है कोई explain? Without modulation, it is not now a radio station. See, without modulation, what I am saying at present is without modulation. So, in case you decide that a radio station in this case will mean there is a high power speaker and on, so that everyone can listen to it directly like I am speaking. You get another person, he also starts speaking, third person, he also starts speaking. If there are 10 persons speaking at a time, what do you get? Nothing, noise. That is why, if just think of, there are suppose 10 FM radio stations in Delhi. Suppose they start transmitting without modulation, means what? They will have number one, a high building. On that building they will place a big speaker so that whole Delhi can listen to that. 1 crore watt. Another station, 1 crore watt, and there are 10 now, and they switch on, all the 10. Can you think of the outcome? Noise. And those living nearby, they will lose their hearing abilities within a month. That means, if you do it without modulation, it will result in what? All signals are mixed, and what you get is noise only. That is why, at present, yes, right now, there are 20 modulated signals available here, 20. But is there any disturbance because of those? No. You can detect one out of that and can use one signal, one station. You have this ability to select. But in case it is 10 persons speaking at a time, you don't have that facility of a selection. You will have to listen to all the 10. That is why, if it is without modulation, it will mean mixing of so many signals, and it will result in noise. Time with you is 2 minutes to write. 2 minutes to write. Minutes to write. Yes, question number 7 is what? Propagation of a electromagnetic waves. Various methods. Number 1 is ground wave. Ground wave communication is what? Ground wave communication is Earth. The signal glides over the surface. The wave glides and follows the curvature of Earth. Let us go through the content. To radiate signals with high efficiency, the antenna should have a size lambda by 4. At longer wavelength, the antenna have large physical size and they are located on or very near to the ground in a standard AM broadcast. So, the point to be noted in this case is that it is AM, that means amplitude modulation, AM broadcast, where the frequency is say 500 kilohertz, even if it is 540, nothing to worry about, to say 1600 kilohertz approximately. Whether it is 540 or 1640, that makes no difference. If the frequency range is this one, that is the program which you are getting from Jalandhar or nearby, you have a scale here on the radio. It is written as kilohertz, 550, 520, 700, 850, 1000, 1250, 1550, and then it is not marked, but it is 1600. In case you want to tune to AM, you will have to change the switch. In case you want to listen to FM, then there is another position. So, if you want to get this one, kilohertz AM, this is what it's applicable. That is, say, from Jaipur, Jalandhar, a place 400 kilometer away, 500 kilometer away. Standard AM broadcast, ground-based vertical towers are generally used as transmitting antennas. So far it is only one part, AM modulation. For such antenna, ground has a strong influence on the propagation of the signal. The mode of propagation is called surface wave propagation, and the wave, underline, glides over the surface of Earth. Ground wave propagation means wave glides over the surface of Earth. A wave induces current in the ground. Now, this part, it is just like as this wave glides, it induces current. These will act as a secondary of a transformer. One winding, primary of a transformer. There is a current in primary. Because of magnetic effect, there is a current in other also, secondary. You call this induction. So, current is induced. This is induced current. Current is induced in the secondary, you can say, and there will be loss of energy. That means, as the wave glides, there is a loss of energy. Equivalent is, on a floor, if you have a glass of water, move it at one position. As it moves along the surface, the water gets absorbed. Similarly, this energy also gets absorbed. That is why, as you move away, attenuation will take place. Signal strength will decrease with the distance. This is what it means. When we say result of absorption of energy by Earth, the attenuation of surface waves increases very rapidly with the increase in frequency. If a frequency increases, high frequency means fast, rapid attenuation. Reason is, yes, why? Reason is, bolo, if a frequency is more, induction is also more, to be covered in chapter number 4, electromagnetic induction. If frequency is high, induction is also high. That is why this is what 1.6 megahertz, FM 101.1 megahertz. Frequency of FM is 100 times this value. Agreed or not? That is why FM is local phenomena. FM is a local phenomena. Maximum distance say 100 kilometers. That is why FM, you get Patiala, if you are 40 kilometers, 50 kilometers away, the strength decreases. FM is a local phenomena. But AM, you can have an AM program here from Jaipur, 500 kilometers. So in AM, the attenuation is less. In FM, the attenuation is fast. The concept is, if frequency is more, attenuation is also more. This is the maximum range of coverage depends on the transmitted power and frequency less than few megahertz. It is 1.6 megahertz. Time with you is 2 minutes. Ground wave propagation. 2 marks question. 2 marks. 2 to 3 minutes to write. 3 minutes to write. B part is what? Yes? Sky wave. Earth. पहले समझ लो. Tropo, strato, meso, ino. Ionosphere. All of you have heard of this? Energy from sun ionizes the air molecule at certain height. Ions are present, you call this ionosphere. This position is, say, BBC London. And we want to get program from the same in India. Suppose we are here. And the distance is, say, 4,000 kilometers. How to get it? Procedure is, send a wave. The wave will hit the ionosphere and gets reflected by reflection. Frequency range is 3 to 30 megahertz. If it is 3 to 30 megahertz, written somewhere, underline that, 3 to 30 megahertz. Approximately wavelength, in case 3 megahertz, what is the wavelength? Anyone? If it is 3 megahertz, Then what is the wavelength? If it is 30 megahertz, 3 means 3 into 10 power 6, and speed is 3 into 10 power 8. So corresponding to this is 100 meters, corresponding to this it is 10 meters, am I right? That means 10 meter to 100 meters transistor. On this there is a switch. Now it is a short wave, it is written short wave. I have shifted it to short wave. Now I can tune to BBC London. How? On this length, it is on this scale, it is written short wave, say 30 meter, 49 meter, other way around, scale is different, 25 meter, 31 meter, 41 meter, 49 meter, 50 meters. So here it is given 25 meter to 50 meters. Falls in this category or not? This transistor can operate between 25 meter to say 50 meters. It is within this is termed as a short wave. Now, what if the frequency is more than 30? It is written somewhere that in case, next line, electromagnetic waves frequency is higher than 30 megahertz penetrate the ionosphere. That means what? If you have frequency more than 30 megahertz, the chances that it gets reflected is less. The reflect होके अगर वापस ही नहीं आएगी, then it is of no use. These phenomena are shown in the figure. The phenomena of bending of EM waves so that they are diverted towards the earth is similar to total internal reflection, or term is reflection. This wave gets reflected from ionosphere. Time with you is 3 minutes. 3 minutes to write. And you can cover space also. Space. Take 3 minutes, koi gal. We'll cover space later on. Space we'll cover later on. 3 minutes to write. Third type is what? Space. Space communication. It is number of examples. Example number 1, your dish antenna in this position and you are getting it from a satellite, geostationary satellite, 36,000 kilometers above the surface of earth. So 1, 2, for a TV tower also, all persons up to this, all persons up to this can see. This is that this point has to be in line of sight. That is why it is also termed as LOS, line of sight communication. See, CBSE I have a question. What is LOS? 1 mark. Answer was line of sight. If it is so, this is one case LOS. In case you have a tower, transmitter here, height of the transmitter HT. You have another tower, tower 2, height of a receiver, range of a transmitter, range of a receiver. Formula, total distance R is equal to range of transmitter plus range of a receiver. Formula is 2 times the radius of R, height of a transmitter, plus 2 times R, height of a receiver. That means here also, so there was a consumer getting signal up to this only, listener. But suppose a listener decides, listener at this point decides, I want to get this program. Ki karna payega? No. Will have to make a personal tower to listen to that program. Then you can do it. This height comes out to be very high. The value is of the order of kilometers. That is why no one affords it. Time with you is 3 minutes. 3 minutes to write. Space wave communication.